I think soon.
Yes, I think it's okay.
Okay, I think we're live. Yes, perfect. All right. So, good morning, everyone. It's 9:32. Neurocino. Here we present papers that excite us, and yeah, this is how we start our week. And today is Marcela presenting interesting paper from Nature, as I see. She sent it already in the chat, so yeah, go ahead.
Yeah, thank you. I think I need your permission to share my screen. If you can allow me. Yes. Oh, yes, maybe I clicked something good, sorry. Yes. Okay, publish. And yes, so I guess you can see the paper, right? Okay, cool. So yeah, as Lily said, I selected this paper that was published in Nature Communication. So it's entitled Network Controllability of Structural Connectomes in the Neonatal Brain. So here, what they aim in this paper was to investigate the development of the network controllability that I will explain in a few seconds what it is during the perinatal period and the effect of the preterm birth. So this network controllability measure is in the framework of the network control theory that is used to explore or to study how brain dynamics arise from the structural connectome. So the controllability is an energy-based measurement that represents the ease of switching between different brain states. So what they did in this study, they used this method in which they take some diffusion MRI from the Developing Human Connectome project, and they explore data from different infants that I will detail later. But this is the overall view of the method in which they use diffusion MRI to build this tractography and build a structural connectome from each individual. And then using this structural connectome, which was built using an atlas, so it's composed of 90 nodes, they explore this network controllability using different models. And in particular, they explore two different measures. So the first one is average controllability, which explore the transitions between nearby states, so with a lower cost of energy. And then they explore this modal controllability that explore the switching between states that require more energy. In the manuscript, they mostly report the results from the average controllability, since the two different measures are not independent. However, sometimes they also refer to the results of the modal controllability. So what I will show you today, it's mostly related to this result of the average controllability. So the switching between states that require very low cost of energy. So what they compare in this paper, so they use data from term infants. So these babies were scanned once, and it was around 2 weeks after birth. So the mean postmenstrual age is 41 weeks. And then they take data from another group of infants that were born preterm. And these infants were scanned twice. So first, around 2 weeks after birth, but it means the mean of age was 33 weeks. And these same infants were scanned a second time in age that was equivalent to those in term. So it's preterm at TEA. So and the mean of the age is similar to the babies that were born at term. So I will, in the results that I will show you, I will refer to these three groups, but we need to remember that the preterm at birth and preterm at TEA are exactly the same group. So at first, what they did, they explored what is the relationship between these different modes of control. So between the average controllability and modal controllability in the three different groups. And what they found is that there is a negative relationship, a negative correlation that was significant for the three groups. And what they observe is that this correlation in the preterm group at birth, so in orange, was significantly more negative compared to the preterm group at the corrected or equivalent age of term. So what they suggest in this with these results is that in the infant brain may prioritize one of the modes as a control strategy than the other through the development. And then what they did, they normalized the data in the three different groups, and they explored if they were spatially similar across the preterm at birth, preterm at the TEA, and in the term groups. And what they observed is that this average controllability was similar, spatially distributed in the three groups. So there were no difference in the distribution of the different brain regions. But then they wanted to explore if this controllability changed during the development. So in particular, by exploring the difference between the same groups, so preterm at birth and the preterm at the equivalent age of term. So what they did, they correlated the number of weeks, so the premenstrual age for the different infants and the whole brain average controllability. And what they observed is that in the group of the preterm at birth, there was a significant correlation between the weeks, the age, and the whole brain average controllability. And then this correlation was not, let me see if it's, was not observed in the other two groups. So what they suggest with this result is that the development rate is higher, so that babies during the preterm develop rapid compared to the babies at term. And let me see what I have here. Yes, and that what they observed is that this change over time was more significant in specific brain regions. And what they found is that this change was mostly observed in the frontal and occipital lobes. So yes, and also, but it's not shown here, it's in the supplementary material, but what they observe is that in the group at term, so the babies at term, there was a significant positive correlation in the modal controllability. So what they suggest with these results, in addition to this other significant correlation in the term group, is that the brain may prioritize this the average controllability mode at first in the very early developmental period, and then they prioritize the modal controllability to support the establishment of a most difficult state for different control abilities. But at first, what the brain of the infant needs is more easy to reach state compared to late developmental stage. So this is, so yeah, they explore this development over time. And what they ask, okay, so if there is this difference that we observe during the development, can we see a difference in the brain controllability in these two groups? So in these two groups where there is no difference in the development rate, but can we see a difference in the whole brain average controllability if we look at the different brain regions? So what they did, they explored the differences at the different in the different brain regions in this between these two groups. So at babies in term that were born at term, and the babies preterm but at the equivalent age. And what they observed is that there was a lower average controllability in different regions. I will show you here. So here we can see in A that this significant difference actually was found in, I have it here. Well, anyways, we can see that in the bilateral temporal lobes and motor cortex and inferior frontal gyrus and precuneus, that the activity or the average controllability was lower in the preterm infants. However, they also found that in the preterm infants, there was a higher average controllability in the bilateral angular gyrus and also in the orbital frontal cortex. So they observed this difference. However, in B, we can see that they didn't observe a difference in the developmental rate in any of the regions. We can see that some regions were had a higher developmental rate compared to others. However, there were not a significant difference between the two groups. And then in C, they explore if there was a relationship between the regional average controllability and the development of this average controllability in the regions with the age. So what they observed is that regions with a higher average controllability developed it more during with age. Okay, I don't know if it's clear, but there is this positive correlation. So yeah, this is so just between these results and the previous one, what they suggest is that at first there is a development that is faster in the preterm infants, and then this development slow down and is equivalent as the babies at term. And but this very rapid development rate is only observed at the third trimester of the perinatal period. It's actually what we observe here. This here. And finally, what they did, they used some simulations in order to explore, okay, we have this connectome in the preterm babies and we have this connectome in the term babies. And they explore using these simulations, what was the cost of energy to reach some activations of the canonical networks that can be found in, for instance, GeoAtlas. And what they observed was that we can see here in the different graphs that these dark box plots are for the group at term, and these light boxes are the group preterm. And these both are at the same age, so equivalent age. And what they observe is that for the term group, there is a higher cost of energy to reach or to activate dorsal attention and limbic networks. And for the preterm babies, there is a highest cost of energy to activate frontoparietal ventral core attention and somatomotor networks compared to the term babies. So, and finally, there is a last analysis they ran that was to compare if behaviorally they could observe some relationship between the scores in different cognitive tasks and these results from the average controllability over time. And what they observed is that there was a significant correlation between cognitive scores measured with these tasks that I'm not familiar with, and the controllability measures at the whole brain level, so the average controllability in the babies. So using all these, based on all these results, what they suggest with this study is that they were able to measure this pattern of controllability since the third trimester of the babies during the development, and that there is a rapid development in the brain controllability that is rapid during the period of the third trimester in the babies, but then it's slowed down. And what it's observed in childhood and also in adults, that there is an inverse pattern in which this modal controllability that is required to reach more distant states has a positive correlation compared to not a positive, but it's the inverse. So in childhood, we observe a higher modal controllability and a lower average controllability that is not observed in the babies. In the babies, is the opposite. So what they suggest is that during development, there is a privilege in this control control of the brain dynamics to reach more close states, for instance, in babies that are required to more motor or sensorial activities for babies. And then for when we are with later ages, we need to activate more distant state in order to reach more difficult or task in life. And yeah, they actually, one of the main also contribution of this paper is that using this approach, that it can also explain or give some light on why some infants that are born at preterm have some problems, for instance, the language problems or more motor difficulties, as we can see that there is a difference in the brain dynamics by using this approach that are altered or different, as they say altered, but I see that they are different between the preterm babies and the terms babies. So yeah, mostly that. And then, of course, they also mentioned some of the limitations of the study, that, for instance, they don't have longitudinal data for the term babies. So they only have a scan twice for the preterm babies. So they cannot talk about behavior longitudinal analysis. And also, they don't have the reasons of the the preterm babies, so why they were born before the expected age, is very different between the different babies. So it can be also other factors that contribute to these results. And finally, that they only use simulations for all the data I presented. So a better maybe approach can be also used by exploring real fMRI data. So yeah, this is the paper that I wanted to share with you. I'm not very familiar with the method, so I hope it was clear, but if you have any questions, we can just discuss.
Thank you so much, Marcela, for presenting this paper. Super interesting. And if someone, yeah, okay. Question, Hervé.
Hi, Marcela. Thanks for the presentation. It was very clear. So during your presentation, I was wondering, because one of the paper I was doing was looking at maturation of the different on the functional maturation on babies, and so one thing I noticed in the literature that is during the development or the first steps is the what some of the papers showed that was the short distant networks they develop, and after the long range networks developed. So I think that was a resting state fMRI on infants and babies. And it seemed that your paper is describing the same thing, that the short distance or the closer nodes are developing faster and after the long distance. Is it right?
Yeah, exactly. It's exactly that. I think because most of the data for the modal controllability, that is what you mentioned as the more long distant, not connections, but states, yeah, were reported in the supplementary material. I look at them, but yeah, but they actually also conclude in the paper, by looking at both results, is that it seems that at first, babies are during the development is more important, seems to be more important these closed states. So they measure here as the average controllability, and then we see this more like flat correlation, and then in the childhood and adolescence they see the opposite pattern, that actually the modal, so reaching more long distance states, yeah, it's privileged compared to the short term or closed states. Yeah, it's like that. They actually, I think the main conclusion at the beginning when in the discussion is that it seems that the modal controllability appears later in time compared to the modal, the average controllability. Yeah.
Okay, just a following question. I was wondering, because one of so when the baby is born, I know we had this discussion that the social brain should pop up. That means the interaction between the baby and the mother should increase the social network. And so I don't know, I didn't check, so I don't know if they are talking about it.
Just in the discussion, they also mentioned that the results can, I don't know exactly from which of the result or which maybe brain, I guess is when they compare the let's see the number of the figure, but in the figure 4A, in which they compare the average controllability between the term and preterm babies at the same age, corrected age for the preterm. And yeah, actually, what they mentioned in the discussion is that this can also kind of not explained, but be a way to understand why some babies has also difficulties, and they mention language. Yeah, here, language, motor and social processing regions. So yeah, for sure they conclude from the results that this can also be interesting to explore the difficulties, not only at the language and the motor levels, but also at the social processing in the infants. Yeah.
Okay. Okay, thanks.
Chris, yeah.
Yeah, thank you for presenting the paper. I had a connection drop when you were talking about the limitations, so I don't know if they mentioned it, but how do they know that what they observe between preterm babies and normal babies is not an effect of like something compensating for being born before term? Like, is it because they are basically saying that earlier in development they see these effects and they are different from later in development, but because it's not a normal development, can we actually say that it is the normal trajectory of a normal normally born baby?
Yeah, actually, I don't think, maybe my bad, but I don't think they mentioned that. I was also confused at some point with the discussions where they mentioned that one is developed early and then the other developed later, like the different controllability modes. Because, yeah, what they mentioned in the limitations is that for sure the one of the main limitations is that they only have one scan in the group of term. So of course they cannot have a longitudinal exploration, so they cannot see the development in this group. But yeah, I don't think they mention that there is a limitation in the preterm group, that it can be due to the that they are preterm, and of course it's not I guess
Yeah,
what
it's not normal for the baby to be born at this age. So I don't know if
but
because the baby is not supposed to be in this new environment with new stimuli. So maybe the baby is just reacting to this other environment, and maybe this is not the developmental trajectory that you would have if you were born in term, right?
Yeah. I don't think they mentioned that, and yeah, it's true. I don't know. It's yeah. Actually, I don't think the development will be the same if you are in other environments. So yeah, no, it's not mentioned in the discussion, at least, or in the limitations in the limitation section. But yeah, I agree that it can be also a consequence of this.
Okay, Eva, if you can fit it in 2 minutes, can be cool.
Yeah, it's just really quickly, because I don't know anything about doing tractography in fetuses, but I don't know if that would be possible, if they mention if anything similar has been done, sort of looking at the normal development in utero.
Yeah, they don't mention that. I have no idea, but yeah, I guess as the data is available in open science, I guess some people maybe have taken this data and have explored that. I don't think they don't have data from fMRI, so I don't think they have explored directly dynamics. But yeah, at least the data is available. So I guess there are some other exploration and studies, but yeah, I didn't see that like explicitly mentioned in the paper. But yeah.
All right. Thank you, Marcela, and everyone who joined on YouTube and here for the discussion. And yeah, I have an exciting week, and see you next week. Bye-bye.